you're all here for the first, what we're calling Lunch and Learn of 2026. Thank you for joining us, for taking the time to be with us here at Datalab. The idea of the Lunch and Learn series is designed to share some of our thoughts on emerging trends in data and analytics and increasingly AI. So the goal is to keep things thought-provoking, practical, engaging. We welcome all of your kind of engagement throughout the session. Please ask questions of Reza. She'll give me a whole list of questions at the end. These sessions are intended to be followed up with a couple of other online sessions. So what we're going to call masterclasses and hands-on labs. And these then get a bit more technical and a bit more hands-on, so you can actually touch and try some of the technologies that we support and figure out how to actually solve some of the problems I'm going to be talking about today. So if you're interested in joining those sessions, I'll share some details with you at the end of the presentation, and then feel free to sign up. The cadence for these types of events going forward is going to be every Tuesday, so the same slot every Tuesday. Join us for one of our sessions to learn something new. So this month's theme is around unstructured data. Next month, we're going to cover data monetization, and in April, we're going to look at developer productivity and using AI type of tools. So the title of today's talk is Your Most Valuable Data is the Data You're Not Using. And what I want to go through over the next 20 minutes, half an hour, and only about 10 slides, thankfully, is I want to talk to you about why this is an AI story. Because the real value of AI doesn't come from just the models itself, but it comes from what you can do with all sorts of different data sets and data types. More importantly, hopefully what I'm going to demonstrate to you is that companies and organizations are sitting on a vast amount of unstructured data. This data sits in things like conversations, documents, transcripts, interactions, and that if we can extract information from there, there's hidden signals and competitive advantage that you can take advantage of. So when we unlock this data, AI will reveal insights that weren't visible before. Just a little bit about me. So my name is Douglas. I've spent the past 20 years designing and building data analytics platforms for organizations across finance, retail, healthcare, and much more. 15 years ago, I helped to found a company called Datalab. We're a data analytics and AI consultancy based in Cape Town, and we're focused on delivering enterprise data solutions to our customers. We've expanded, and fortunately for me, we have a company in the UK which allows me to travel back there regularly. And over the last 15 years, our business has evolved along with the needs of our clients. So we started out as a Microsoft partner, and over the last 15 years, we've transitioned our business to be more diverse, looking at cloud-first technologies. So who are Datalab? As I mentioned, we've evolved, we've grown from a Microsoft partner into really offering our customers a cloud-first kind of approach to delivering on technologies. And whilst we're not going to cover technologies in this session, some of our other sessions, the masterclasses and the hands-on labs, will give you an opportunity to experience these tools firsthand. So let's get into the meat of today's presentation. There is no AI strategy without a data strategy. And coming from a traditional data engineering background, we've learned something very simple, that there's a whole load of hidden signals inside of unstructured data. Before I get into the actual problem statement, what I want to kind of talk about first of all is when we go and talk to customers about what is AI, and the typical response is we need to become an AI-enabled business. This means lots of different things to different people. And what we're seeing in practice is that companies don't really have a clear picture of what that actually means to them. So as an example, we've got on the screen here the Gartner hype cycle. And this is a great illustration of the challenges that are faced by this kind of broad and fragmented AI landscape. AI isn't a single technology. It's an ecosystem of different capabilities, each at different levels of maturity. And so it's really important when we're talking about AI to really understand what it is that we mean. So if I zoom in on this a little bit and just take some examples here. This is the 2025 hype cycle, and we can see that the vast majority of new technologies here are kind of either foundational AI concepts. So here we're thinking about things like domain-specific Gen AI models, or they're innovations that are dependent on AI. So things like decision support, AI agents, vibe coding, these things require like large language models to actually enable their capabilities. And so it's this diversity that organizations are typically finding overwhelming. So when we talk about AI, there's different use cases for different departments, different problem statements, and actually like enabling those within the organization is a challenge. So the best way to try and like combat this is to start thinking about AI in a very structured way. And so the one way to do that is to think about AI as an ontology, to put things into classifications and organize AI use cases into clearly understandable categories. And so this helps us move from, lost my train of thought now, but this helps us kind of organize business cases. So what I've done here is I've intentionally made a really simple ontology to try and just kind of illustrate where we find different use cases for AI, and hopefully to enable the conversation a bit further on in the presentation. So the very, very bottom here, we've got engineering use cases. So these are kind of foundational. This is where data works and lives. So this is using AI for data ingestion, data quality, building AI pipelines. It's the layer every AI use case kind of further downstream will depend upon. It's the least glamorous, but nonetheless, it's really, really important. Building on top of that, we have kind of AI intelligence layers. So this here is where we see typical kind of AI use cases: discovery and search, predictive analytics and machine learning, generative AI, creating loads of like cool images, videos, audio, and then conversational AI. And so these are the typical kind of use cases where users start to interact with large language models and generate content. Then we find operational like AI use cases. So this is where AI meets business operations. So this includes things like process automation, decision support, and then things like personalized intelligence. And then the kind of final layer in this ontology is to really start thinking about agentic workflows. So this really is kind of the emerging frontier at the moment, where we're using AI to not just assist us, but to actually act on our behalf, coordinating tasks, managing processes, and doing things kind of end to end in the background for us. All the time, though, when we're building these AI kind of use cases, we need to be able to kind of manage and govern these systems. But the one takeaway I want you to take away from this particular slide as well is these are all well and good, and we can implement these really cool AI like solutions. But the one thing that these AI solutions are going to do for us is generate even more data. We're going to generate logs. We're going to generate whole conversations with AI. We're going to generate all of these other kind of hidden insights that we now need to kind of store, curate, manage to be able to kind of build and govern our AI solutions. So this brings me on to kind of the next part of my presentation, which is really to talk about the engineering kind of function and how we can use AI to build or help us in the data engineering space. Before I dive into that, I want to kind of contextualize the kind of necessity for this, and just talk about some of the kind of numbers around data and data growth. So to grasp the true scale of kind of data creation, there's around 181 zettabytes of data that were created in 2025. And so to contextualize that, 1 zettabyte is equal to 1 trillion gigabytes of data. So what that means is that every single day we're creating 2.5 million terabytes of new data. That's the equivalent of around 29 terabytes of data every single second, and that's 24/7, 365. It's estimated that every individual on the planet, or the average, is that we're generating some form of digital footprint every 18 seconds, whether we're sending emails, clicking on something, navigating a website, interacting on an app on our phone. We're constantly generating digital content that's being stored and now needs to be analyzed. So we've got data that's growing really, really, really fast, and it's estimated that it's growing at around 25% year on year. But within that data ecosystem, the big data that's growing is unstructured data. So of all that data, of all the 181 zettabytes of data, 80% of it is created as unstructured data. So this is messy human contextual information buried in things like documents, emails, images, videos, audio, PDFs, chat logs, any kind of free text that we store anywhere. And so as this data is accelerating, the volume of that data is actually being consumed by unstructured data. It's growing 3 times faster than structured data. And so we've got this kind of hidden wealth of information that's not really accessible to us. And so this is where AI engineering can help us solve some of these problems. So just to recap, we've got 181 zettabytes of data in the kind of data sphere as at the end of 2025. It's growing exponentially at 25% year on year. We've got 80% of that data is unstructured, and it's growing 3 times faster than the kind of data that we're typically used to managing, structured data. And so while these might seem like challenges, to us, these equal opportunities. So as a way of kind of demonstrating like what the opportunities are, I've taken investment management kind of industry as the kind of use case. We're going to go through now like a case study, but this could equally be like any other industry with similar challenges and similar opportunities to using unstructured data. So we just think about some of the kind of departments that we might find inside of any kind of financial or investment management institution. You've got things like investment research and analysts. You've got people managing customer experience. You've got product development teams, and then you've got the human resources department. And the kind of data that they're typically like used to managing is in terms of structured data is things like pricing data, information around trading volumes, transactional history, holdings in order to be able to kind of do customer reporting, maybe asset pricing data and trading volumes, and then compensation data for traders and for operational staff. But this could all be augmented with unstructured data sources. So we could be looking, if we're looking at research teams, regulatory filings, ESG reporting, earnings calls, research reports. If we're talking about customer experience, we could be analyzing call center transcripts or web chats, or just looking at client feedback online. If we're looking at product development teams, we could be looking at social media, competitor announcements, or getting information back from our third parties or intermediaries that we work with. And for human resources, we can be managing performance reviews and internal communications as mechanisms to help us manage our human capital. So for us, when we add structured data and unstructured data, we can have kind of exponential impact. And so I'm not going to go through all of that, the kind of impacts at the bottom, but the one area that we're going to focus on in terms of a case study is to really look at investment research and see the impact of looking at unstructured data to find hidden signals in data. So the case study that I'm going to take you through now is a case study of S&P Global Market Intelligence. And what they actually ended up doing is they took 192,000 earning call transcripts. So earning calls follow a really simple but familiar structure. So there's prepared remarks from executives, and they present their company story, and then analysts have a Q&A kind of session. They ask questions that investors are actually like interested in, and then the executives have to respond to those questions in real time. And so using large language models and vector embeddings, they uncovered two high impact communications. So the one was on topic alignment. So does the executive answer the questions that they're asked? And the second one was proactiveness. Do the executives address key concerns up front? So when they're actually doing their presentation, have they already thought about what their investors are actually interested in? Have they actually addressed those questions in advance? They're not actually waiting for analysts to ask them and try and get the information out of them. And so what they found was quantifiable signals in those communications that governance quality and the way in which people were presenting had a clear kind of link to performance. So how did they actually do this? So they took those unstructured call transcripts. They took that data and they processed it. So they turned it into or summarized those transcripts, and they did something called chunking, which is taking like large chunks of text and turning it into smaller chunks. They then vectorized that data into 3 different categories: the prepared remarks, the analysts' questions, and the executives' answers. And then by comparing these different data sets, they were able to get insights. So by using the analysts' questions and the prepared remarks, they generated a proactiveness score. did the executives already address some of the concerns of the analysts in their prepared remarks? And did the questions that the analysts asked, were they actually answered in advance? And then the second thing they did is they took the analyst questions and actually compared it to the executive's answers. What they were looking for was whether the executive was engaging in terms of their response, or whether they were kind of trying to avoid the question. So they did this on aggregate, and what they found was that that executives and boards that were highly engaged, they were proactive, and they were on topic over the 17-year period from 2008 to 2024, they found that they outperformed a benchmark that they'd created by 2.5%. So in terms of the performance of their companies, they outperformed the benchmark of the cohort that they had analyzed by 2.5%. On the flip side, those boards which were reactive and off topic and typically trying to hide the performance of their company away, they underperformed by 2.5%. And so, the delta between those is almost 5% difference in terms of the best performers to the worst performers. And so their key takeaway was that clearly prepared and aligned communications from executives wasn't just good for governance, but it was actually kind of a lead indicator to the performance of the stock. It also gave the analysts confidence in the actual board. And so it's kind of a self-fulfilling prophecy in a way. And so, hopefully that's just one example that you can see where we take unstructured data and we analyze it, that we're able to kind of find these hidden signals in the data, and that we can use those hidden signals to actually drive strategy or to be used as kind of additional lead indicators. This is the last slide that I've got, so I've actually gone through these pretty quickly. But before we close, I want to leave you with kind of 3 core ideas that capture how AI is changing the way we build and operate. So first is kind of development practices. So we're shifting away from traditional software engineering into a world where the vocabulary is actually changing. And this is one of the biggest challenges that we find, is that we're starting to use completely different language than we have before. We're talking about things like prompts and models. And these systems are now becoming more kind of autonomous. They're becoming more complex. And so we're going to need to find new ways of actually like working with code, working with governance and observability around these kinds of solutions. The second one is kind of design patterns. So we're dealing with completely different kind of building blocks to developing solutions. We've got agentic workflows. We're talking about things like vector search. We're talking about orchestration. And these aren't just add-ons. They're becoming kind of architectural building blocks that we need to put together to kind of build the new wave of solutions. So understanding these patterns, how they're combined, this is going to become a core competency for data engineering teams. And then I guess the third kind of big challenge to delivering these kind of solutions is, as these kind of systems become more intelligent and more autonomous, it's how do we do testing? That's not going to be good enough on its own anymore. We're going to need things like continuous observability, real-time feedback loops. We're going to need kind of humans in the loop to kind of manage these solutions. We're going to need to put down the appropriate guardrails and governance. And so these are kind of some of the challenges that we're finding organizations are having to work through so they can enable these kinds of AI solutions in the future. And so we have the privilege as Datalab to help our customers on the journey, learning collaboratively with them in terms of like how these things are actually deployed, what the best practices are, and how to kind of instill some of these solutions in their environment. So that's pretty much everything that I've got to kind of take you through today. If you are interested in the case study, there's a formal case study that you can get to through this QR code or through the link below. And we'll share all of the resources that we use to kind of put this presentation together today. It's a really good case study. There's a great podcast that goes along with it. It's definitely worth a listen. It goes into a lot more detail as to the technologies that they use, the processes, and the kind of metrics that they identified. I really just took some of the kind of high level points from the podcast and from the case study today. And then if you're really interested in joining the kind of the next 2 events, in the next event, we're going to go through into kind of a little bit of a masterclass. So there we're going to deep dive into the technologies that we use to kind of solve this problem. So this was all done as on the Snowflake platform using a lot of their kind of AI features. And so we'll just go over those and demonstrate how they work. But if you want to get your hands dirty, you want to touch and try and see how you can actually build this for yourself, there's actually a data set available from S&P, which has the transcripts, and we'll take you through in a 2-hour session how to build the solution for yourself. It'll be a high-level kind of version of the solution, but it will give you an idea of the tools and the technologies and how easy it is to put these things together if you've got these kind of business cases. And then finally, if you are interested in Snowflake and you are in Cape Town and Joburg in March, then there are these 2 sessions called Data for Breakfast. They're really worth attending. You get to hear other case studies like the one I presented to you today in terms of how people are using Snowflake to solve business problems. We'll be there. We're sponsoring Data for Breakfast this year in both locations. So you can come along and talk to myself, Reza, and the rest of the Datalab team. And that's all from me. I don't know if there are any questions, but if you want to reach out and you want to find out more about the kind of work that we do, more about these kind of challenges and how to solve them, or do you just want to have a cup of coffee, then you're welcome to reach out to us. Cool. If there's no questions, then thank you very much for joining. It was a whirlwind slide deck, so I can prepare more slides next time around. And thanks very much for joining, and we'll see you at the masterclass, hopefully.